In this video, we're going to learn about the circuit element known as an operational amplifier. We will usually shorten that down to just an op-amp. And I have three different diagrams trying to show you what an op-amp is. The top one is the actual schematic of an op-amp you could buy in the store. This is showing you what's going on inside of the chip that you bought. I usually refer to this as a real op-amp, that's what it is. However, it is not very useful to us in this class. It has certain things inside of here that we don't learn about, like transistors. It's just way too complicated for the level of class that we're dealing with right now, and someday you can learn more about that, but it's just too much for us. So we need a more simplified mathematical model. Really, if you look at the top picture, you probably can't tell anything what's going to happen if you try to turn on the circuit in some way. However, the second picture is going to help us significantly more. So it's not the true op-amp, but it's kind of close. The idea behind it, it's what I usually call the fake real op-amp in my classes. So again, it's not what's really happening, but it's a good idea, a good mathematical model for it. So we take a look at this op-amp, we see that there are in fact three terminals. There are going to be two input terminals. One we're going to call the positive terminal, one we're going to call the negative. Then there's going to be one output terminal. So right away you can see that this device, this op-amp, is a three-terminal device, which is something we have not seen before. Previously we had resistors, we had voltage sources, current sources, independent, dependent. All of those were always just two-terminal elements, and now we have a three-terminal element. So the idea here is that you hook up two voltages to your input terminals, one to V plus and one to V minus, and you are going to have a resistance between them here. It's called the input resistance. And you are going to measure the voltage between them. This is the VD. That's the voltage between the positive terminal and the negative terminal. And then separately in your circuit, you are going to have this dependent source, this dependent voltage source here. And that dependent voltage source output is going to be A times VD, where A is some multiplier that is specified in the actual design of the circuit. For us, we're going to end up seeing what happens as the multiplier goes to infinity. But regardless, we'll just go ahead and do that here. And then we have this output resistance, and you're going to measure the voltage on the output. Now what we could do is we could go ahead and draw a circuit using this specific diagram here. And they give you specific values for the resistances and for the A. And they ask you to calculate what the output voltage is given the two input voltages and so on. And that's perfectly fine. What you're going to see though is that it ends up being a whole lot of work, and it turns out there's a much simpler way to get the same answer, and that's what's going to be called the ideal op-amp. Or if you want to call it the fake op-amp. It basically cuts out all of the actual work of what's going on inside the op-amp, and it simplifies everything down inside. It ignores it all and just says we have this three-terminal device. You have your voltage coming in the plus side, you have your voltage on the minus side, and then you have your output voltage. And then there's going to be these rules that specify how we're going to handle this device. The first rule says that the voltage of the positive side is guaranteed to always be the voltage of the negative side. At first, that probably doesn't make any sense because we're trying to measure the difference between the two input voltages, and if they're the same, then the difference is zero. That doesn't make any sense. Well, I told you this is the mathematical model That's going to give us basically the same answer with much, much less work. So it's what we're going to go with. And then the second rule is that the current on both of the input terminals is going to be 0. So if you have these two rules involved, then that means you're dealing with an ideal op amp. And every op amp problem we're going to solve from here on out is going to be an ideal op amp problem. So what that means is when you have a more complicated circuit and you're trying to analyze it, start with these rules and see what equations you can work out based on them.